Today we'll start with a new chapter, linear programming. This is given as chapter number 12 in your syllabus. You know the syllabus for the academic year 2020-21 has been reduced. Accordingly, we have very few topics. In this video, we will have introduction, linear programming problem and its mathematical formulation, different types of linear programming problems. We will study this chapter in the form of questions and solutions. There are 7 marks total in your board examination of 6 marks and 1 mark each. There will be no 2 marks, 3 marks, 4 marks or 5 mark questions. Hence, you please study this with concentration. It is easy to score 6 marks provided you study with full concentration and practice it. Please note down and use graphic sheet. We will be needing a graphic sheet for solving linear programming problems. Let us start. Introduction. The running of any business involves many constraints like financial, space, resource, power, etc. The objective of any business person would be to make profit maximum under all constraints. The linear programming problem is the problem of optimizing an objective function. Please note objective function. And under a given set of constraints. When objective function is a profit function, the optimization is to maximize the profit. In the case of cost function, the optimization is to minimize the cost. Linear programming problem. A problem in which we find maximum given by the relationship z is equal to ax plus by called the objective function. That is, z is equal to ax plus by is called the objective function subject to number of constraints. So restrictions of the form of ax plus by less than c, ax plus by less than or equal to c, or ax plus by greater than c, or ax plus by greater than or equal to c is called the linear programming problem. Extreme point theorem. Let R be the bounded feasible region for a linear programming problem, and let z is equal to ax plus by be the objective function. So the objective function, which can be either maximizing profit or minimizing cost, is given by the relationship z is equal to ax plus by. Extreme point theorem states that maximum or minimum values occur at some corner point. Hence, our solving approach to trace these corner points in a graph. Graphical method of solving linear programming. We will solve all the problems using graphical methods. There are certain steps which we have to follow. First, draw a linear graph of the given constraint, linear constraints. Okay. Note that for all these linear programming problems, x is greater than or equal to 0 or y is greater than are equal to 0. That means the graph will be drawn in the first quadrant. Step 2. Step 2 will be to find the intersection of the and mark the shaded region of the constraints curve. So the linear equations will be generally 2 or 3. And these constraint lines graph will be drawn on the graph sheet, and we will mark the shaded region in step number 2. In the third step, we will find the mark the coordinates, note the coordinates of each vertex, that is the corner point. So step 4, the objective function at each, then we will calculate z. Z is equal to the given function ax plus by for different values of x and y at each vertex. So for this z value, we get something maximum. M is the maximum and M will be the smallest value. So the profit can be maximum and it will be represented, the maximum value will be represented by capital M and minimum value by small m. And so step 5, if the feasible region is bounded, then M is called maximum value of Z and small m is called the minimum value of Z. So in this step 6, if the feasible region is unbounded, then M is called the maximum value of Z. If open half plane determined by Z greater than M has no point in common with feasible region. Otherwise, Z has no maximum value. Similarly, small m is called minimum value of Z if open half plane determined by Z less than M has no point in common with feasible region. Otherwise, Z has no minimum value. We will take all types of problem in this section, in this video, and solve it. You will understand more about this step 1 to step 6 in solving the numerical problems. Let us take up question number 1. Question number 1 says maximum p is equal to 3x plus 5y. This p is equal to 3x plus 5y I have written in reading to state that this is an objective function. In the theory, we had told z is equal to ax plus by. So here in the given problem, it is p is equal to 3x plus 5y. Subject to constraints are given. There are 3 constraints. First constraint equation is x plus 2y is less than or equal to 20, and second constraint equation is x plus y less than or equal to 50. And the third relationship is y is less than or equal to 6. So there is no x term in the third equation. So and xy as always is greater than or equal to 0. So these 3 equations of constraints given in blue color are very important. We have to solve the problem using this constraint first. Let us solve it. So we will copy down the first equation, x plus 2y, it is given as less than or equal to, but we will put it equal to 0. This is the first important point. Note down the constraint curve, x plus 2y is equal to 20. So less than or equal to is substituted by the sign equal to. And the next constraint is x plus y is less than or equal to 15. So that is written as x plus y is equal to 15. And the last constraint is y is equal to 6. So these are the 3 equations. Now we have to find the value of, we have to draw the line in the graph using this relationship. Let us take line 1, that is x plus 2y. Here in this, we will put x is equal to 0. So when we put x equal to 0, we get this first term is 0, 2y is equal to 20, or y is equal to 20 by 2, 10. So it is written here. So x is 0, then when x is 0, y is 10. In the next step, we put y is equal to 0. That is y is equal to 0 here. This second row. Second row. First next step is 0. You put y equal to 0 in this equation. So if you put y equal to 0, then x will be equal to x plus 0 is equal to 20. Therefore, x is equal to 20. So we start with x is equal to 0 and find y. And then we go to y is equal to 0 and find x. So x and y of this line equation have been found. Next we will repeat the same thing for the second line, that is second constraint, x plus y is equal to 15. So here also same thing. First we put x equal to 0. If you put x is equal to 0, y is equal to 15. Therefore, it is written in this table. So x is equal to 0, y is equal to 15. So next is we will put y is equal to 0. So y is equal to 0 we have put. If you put y is equal to 0, x is equal to 15. This is written here. And y is equal to 6 is already given. So there is no table here because x is not present in the given equation. Now we draw the graph of line x plus 2y equal to 2, x plus y is equal to 15 and y is equal to 6. So there will be 3 lines. These are called the constraint equations and identify the feasible region. So let us draw the graph. Graph is to be drawn very carefully. Please take a graph sheet, scale and a pencil and mark all the points along with me. Because of time constraint, I am showing the graph, the whole graph. I will give you step by step how to draw the graph. Please first select this point O, this point O. In the graph, this is the two lines are drawn, one horizontal line and two second horizontal line. So this is x-axis and this is y-axis. And mark the point 0, 0. This is the origin O represented by 0, 0. The next line is, we will draw the equation of line x plus 2y. Here, x plus 2y. We know here, when x is equal to 0, y is equal to 10. So this is the point x is equal to 0 and we will mark the point y is equal to 10. Y is equal to 10 is here. Y is equal to 10 is here. This is y is equal to 10. Now next we will select y is equal to 0 is here. When y is equal to 0, x is 20. So x is 20 is the point is here. This is the x is equal to 20. So we will join this line. Here you see, this is the line we will join. So we will get equation x is equal to 2 plus x plus 2y is equal to 20 is this brown line, brown colored line. Next we will draw x plus y is equal to 15. In this case, when x is equal to 0, y is 15. So x is equal to 0 is here and y is equal to 15 is here. This is y is equal to 15. So next point is when y is equal to 0, x is 15. So therefore this is y equal to 0 and x is equal to 15 is here. So you see, that is why it is marked, this is 15. So now we will join the equation of line x plus y is equal to 15. This is the straight line. It has not come straight, it has come curved. Okay, you make it in your graph. This is a green color. X plus y is equal to 15. Now there is another point, y is equal to 6. So you know here x is not given, so x is 0 and y is equal to 6 is here. Y is equal to 6. This is y is equal to 6. So we have drawn three given lines. That is x plus y is equal to. Therefore, now we will draw x is equal. Now we have drawn all the points and we will mark. This is the line x plus 2y is equal to 20, the brown colored line, and x plus y is equal to 15. This is a green color, light blue color, and this is horizontal line is y is equal to 6. This is y, this point you please note it is 6 comma 0 0, 0 0 comma 6. That is y is equal to 6. So these are the, now we have got this. Now at intersection point we have to find out the value of C. At intersection point we will find the value of C as, from the graph it is 10. That is x is equal to 10 here and y is equal to 5 here. And similarly, the intersection point of the horizontal line and this brown line is 8 and 6. From the graph, you can point out 8, 6 here from the graph. You note down in your graph. Okay. So this is A06. From the graph, B is 806. That is the intersection point. And C is 10, 5. And D is as it is, we know 15, 0 and 0, 0. And identify the feasible region. The shaded portion A, B, C, D and O represents the feasible region in which all constraints of the problem are satisfied. That is, this shaded portion, filled up portion is the feasible region. Therefore, now we will know we know A is 0, x, 0, 6. 0 is x, y is 6. So we will make a tabular column. We will write vertex. Vertex is, that is the point A, B, C, D and 0. Origin is O. O is origin. Vertex are A, B, C, D. So now the coordinates we will write x for this is origin is 0 0. Hence we will take this equation p is equal to 3x plus 5y. That is the objective function. P is equal to 3x plus y. We will write here, which we are supposed to maximize in this case. So P is equal to 3x plus 5 is written. So in this table, the first column is vertex, second column is x coordinate, third column is y coordinate, and fourth column is the objective function. Sometimes it is written as z, or sometimes it is written, if we have to maximize, it is a profit function. If we have to minimize, it is the cost function. So it is written in the fourth column. When both x and y are 0, you put x is equal to 0 in this equation and y is equal to 0. You will get 0 plus 5 into 0 is 0. So therefore P is 0 at the origin. Next we will take up vertex A. At vertex A, we have the coordinate 0, x is equal to 0 and y is equal to 6. Therefore, P will be equal to Therefore, P will be equal to 0, that is 3 into 0 plus 5 into 6, that is equal to 30. 5 into 6 is 30. So next vertex is B, where x is 8 and y is 6. Therefore, P is equal to 3x, 3 into 8 plus 5y, 5 into 6. That is equal to 24 plus 30. That is equal to 54. So for vertex B, the value of P is 54. Next point is C. So in C, the value of x is, from the graph, x is 10 and y is 5. So we will substitute these values in the objective function 3x plus 5y. That is 3 into 10 plus 5 into 5. 5 is here. That becomes 55. So P equals 55 at point C. Now next point is D, that is this point. Here x is equal to 15 and y is equal to 0. Therefore, the given equation objective function p equals 3x becomes 3 into 15 plus 5y. Y is 0, therefore it is 0. That becomes 45. Therefore, from the above table, we observe that maximum value of P is 55. You please note here it is 55. If you compare all these, 55. And the corresponding values of X is 10 and Y is 5. That is the required answer. Question number 2. Minimize C is equal to 8x plus 64y. Subject to 3x plus y is greater than or equal to 6, comma, x plus y is less than or equal to 4, comma, x plus 3y greater than or equal to 6, comma, x, comma, y are greater than or equal to 0. So these four constraints, that is the constraint subject to means constraints. 3x plus y greater than or equal to 6, x plus y less than or equal to 4, x plus 3y greater than or equal to 6, comma, x and y, which is very common for all the problems, that indicates the graph lies on the first quadrant greater than or equal to 0. So this is a minimizing function. That is cost is equal to 80x plus 64y. We have to first take the constraint equations. So let us solve it. So x comma y greater than 0 is noted down as it is. Then we have to write three given equations of constraints by substituting greater than or equal to sign or less than or equal to sign by equal to sign. So we will do it as it is. So 3x plus y is equal to 6. X plus y is equal to 4. And x plus 3y is equal to 6. These are the three constraint equations. We will calculate the value of x and y to get at least 2 points for drawing a line. We select x as 0. First step, we select x as 0 for easy calculation. So in this equation, that is 3x plus y, we put x is equal to 0. Then we get y is equal to 6. So that is written in the second row, second column. Now, to find the value of x, to get the second point, in the next step, we will put y is equal to 0. So then we will put y is equal to 0, which is shown in the second row, third column. So in this equation, if we put y is equal to 0, we get x is equal to 6 by 3 or x is equal to 2. Here, thus we got 2 points required for drawing the line equation 3x plus y is equal to 6. Now we will take up the case of the second constraint, that is x plus y is equal to 4. Therefore, to draw this line, as in the previous case, we put x is equal to 0 to get y is equal to 4. And in the next step, we put y is equal to 0. So here, this is 0. If we put y is equal to 0, we get x is equal to 4. So here also, for second equation, we got 2 points. Now we will take up in similar way the equation for the third line. So here also we put x is equal to 0. If you put x is equal to 0, 3y is equal to 6 or y is equal to 6 by 3 equals 2. So we got the first point 0, 2. And then The next step, we put y is equal to 0. Here we put y is equal to 0. We get x is equal to 6. So now we have got 2 points each for each of the lines. 2 points for each of the given constraint equation. The next step is to draw the graph for this point. We see the graph here. Select the graph sheet and draw two lines, a horizontal line OX and perpendicular line OY. And select a suitable scale. To select a suitable scale, you have to see the maximum value of x in these three tables. In these three tables, you will find the maximum value of x is 6. So you take the scale in such a way that about the maximum length occurs is more than the 6. So about 10 or 20 squares you can select to graph 20 centimeters, 10 or 20 centimeters, and mark the scale accordingly. So you draw, I first to select the point, that is equation 3x plus y. So 3x plus y, so we have got the first point 0 and 6. When x is 0 is here, y is equal to 6. So this is y is equal to 6. So next point is 2, 0. So when when y is equal to 0, y is equal to 0 is here and x is 2. So x is 2 is here. You join this point to get this line. This line you will get it. Please draw in your graph using pencil, scale and a rubber if it is drawn. So you correctly you join. After next step, next we will draw the line x plus y is equal to 4. So for this, the first point is 0 and 4. X is 0 is here, y is equal to 4 is here. This point. And the next point for this line is 4, 0. X is equal to 4 is here, x is equal to 4 is here, and 0, y is equal to 0, that is x-axis. So this you can draw, you can join this point. This is the second line. Now we will draw third line, that is x plus 3y equals 6. For this line, the first point is 0 and 2. So when x is equal to 0, y is equal to 2. Y is the on vertical axis. This is where x is 0 is this and y is 2 here. So this is the first point for the third equation. And next we draw the next point, that is 6, 0. X is equal to 6 is here, x is equal to 6, 0 is here. So x equals 6 here and y equals 0 is here. So you can join these 2 points, straight line. Okay, my graph has not come properly. You can use scale to draw a straight line. Okay, now we have got all the 3 points. All the 3, we will write the equation for each line. So this is, we will write 3x plus y is equal to 6. Then x plus y is equal to 4. Okay, this is the second, and x plus 3y equals 6 is the third line. So these lines are intersecting one another at point B. B is here, B, C and D. So these 3 points you have to identify and draw the shade portion and feasible regions. You draw the feasible regions. Now you will have a confusion whether you have to take a lower feasible region or upper feasible region. For that purpose, you have to examine the given constraint equation. You see the third equation. Third equation is x plus 3y should be greater than or equal to 6. So this is the line x plus 3y is greater than or equal to 6. So the upper portion of this line is greater than or equal to 6. So this is the feasible region. If the third line equation had been given less than or equal to 6 means you should have selected in the lower region because it satisfies only less than or equal to. Because it is greater than or equal to 6 in the third equation, this equation, only this region, this is the feasible region. Please select the feasible region very carefully by practicing replaces. The shaded region BCD represents the feasible region in which all constraint problems are satisfied. Therefore, you mark the next table with 4 rows and 4 columns. The first column is vertex BCD, the point, and the next column is XY, coordinates XY. You see here the point, the coordinates of B and C are 1 and 3. This is measured from the graph. If you have drawn the graph correctly, you will get the correct values. Therefore, B is 1 and 3, for which the objective function, that is objective function, given objective function is C is equal to 80x plus 64y. So in this equation, we substitute the value of x and y. That is, C is equal to 80 into x. X is 1 year for point B and 64y. 64 into value of y here is 3. If you simplify this, we will get the value as 272 for point B. Next, we take up the point C, whose coordinates are x are 3 and 1. You see here 3, x is 3 and y is 1. Therefore, the given equation 80x plus 64y becomes, if we substitute the value of x and y for point C, we get 80 into 3 plus 64 into 1, that is equal to 304. Next, we will take up the coordinates of point D. Coordinates of point D from the graph are, so please note that this D is x is equal to 3 by 2 from the graph and y is also equal to 3 by 2 from the graph. And hence these values we substitute in the equation. C is equal to 80 into 3 by 2 plus 64 into 3 by 2. That is equal to 260. If you compare the values of 3, that is values of B, C, D from the given objective function, we are required to select the minimize because in the question they have asked to minimize. So it is the first value for B is 272, C is 304 and D is 260. So we have to choose the minimum value, that is 260. Therefore, from the above table, we observe that minimum value is 216 corresponding to x 3 by 2 and y is 3 by 2. That is the answer. Now we will take up the next question. Question number 3. Maximize z is equal to 5x plus 2y. That is the objective function. Subject to, there are constraint equations also. 4x plus 6y less than or equal to 36, comma 2x plus y less than or equal to 10, and finally x comma y is greater than or equal to 0. Now we draw the graph. Now we calculate the equations. Solution. Subject to x comma y greater than 0 is a common for all the equations. So the two given constraint equations are 4x plus 6y equals 36. That is, we have substituted less than or equal to sign by equal sign. So 4x plus 6y is equal to 36 is the first constraint. The second constraint is 2x plus y is equal to 10. So we will draw tables, small tables for finding the 2 points for drawing the graph of equations. So the first equation is 4x plus 6y is equal to 36. We will put x is equal to 0 in this equation. When we put x is equal to 0, 6y is equal to 36 or y is equal to 36 by 6 is equal to 6. So it is written here. So when x is equal to 0, y is 6. To simplify our calculation. So next step is to put y is equal to 0. This is 0 here. 0 in this equation. When we put y is equal to 0, we get 4x plus 0 is equal to 36. Therefore, x is equal to 36 by 4 equal to 9. So value of x is written in the first row, third column. So we have got 2 points. That is, first point is 0, 6 and second point is 0, 9 for drawing the line equation of line 4x plus 6y is equal to 36. We will take up the next equation, 2x constraint equation, 2x plus y is equal to 10. So the second table becomes, when we put x is equal to 0 in this equation, we get when x is equal to 0 here, y is equal to 10. So this is put in this column, second column. So when x is equal to 0, y is equal to 10. So in the next step, we will put y is equal to 0. So here y is equal to 0 we have put. When we put y is equal to 0 here, the equation becomes 2x is equal to 10. Or x is equal to 10 by 2, that is equal to 5. So for second equation also we have got two coordinates. So the first coordinate is 0, 10 and the second coordinate is 5, 0. Now we draw the graph for these constraints equations and identify the feasible regions. So in order to draw the graph, you select you take out your graph sheet, rubber, scale and pencil. So on the graph sheet, you select one point O, that is origin, on the left side of your graph sheet. That is, you leave about 20 centimeters from the end, 2 centimeters from the end, and select point O. And you draw a horizontal line OX as my red pointer is showing. So you draw an horizontal line OX. And on this you draw a vertical line OY in this manner. So these arrows indicate the coordinates X and Y. So first you have to draw the line, graph of line 4x plus 6y is equal to 36. The first point here is 0 and 6. So when x is 0, y is 6. So y is 6 is this point. So we will draw this line. The next point in the table is 9 and 0. So when x is 9, y is equal to 0. Y is equal to 0 is the horizontal line here, x-axis, and 9.9 is this. So x is 9. So you select the point 9 on the graph on the x-axis and in such a way. So now you join these 2 points. When you join these 2 points, you get the equation. So this is the equation. Now we will take up the second line, 2x plus y is equal to 10. So here, in order to draw the graph of this line, constraint line 2x plus y, first put x is equal to 0. When we put x is equal to 0, this term becomes 0. Therefore, y will be equal to 10. So these 2 points, 0 or 10, are given here. So 0 or 10 is selected. So when x is equal to 0, y is 10. This is that point. Now we will take up second point. The second point here in this table is X is 5, Y is 0. So X is 5 is this point, and 0, 5, 0 is this point, this second point. So now we join these 2 points. So we have drawn equation for line 2x plus y is equal to 10. These two lines intersect at point B. Now we have to find the coordinate of point B. Point B, you can find from the graph. You measure this point on x. If you find x here, you will get 4. On the x-axis on the scale, you will read it as 4. Sorry, 3. I come back, I repeat. For this point, if you read the scale on the x-axis, it is 3. And similarly, if you read the scale on the y-axis, it is 4. The coordinate of B is thus 3, 4. So, we will now mark this, shade the region. This is the feasible region. Shaded portion in this graph, the gray color is the feasible region. So, we have identified this feasible region. The shaded region O, A, B, C, O represents the feasible region in which all constraints of the problem are satisfied. So in this region, all the constraints are satisfied. So now we will calculate the objective function. Objective function is z is equal to 5x plus 2y. So objective function, so we have to maximize it. So we have to find the value as per the question, maximize z. So therefore, now we will calculate we'll trace the vertex of each point. So origin O, we know 0, 0. So therefore, in this equation, if we put x as 0 and y as 0, we get z is equal to 0. Next, we will move to the point A. A is coordinates are 0 and 6. We will write down x is 0 and y is equal to 0. It is written in A, point A, x is 0, y is 6. Therefore, we will substitute these values in the given objective function 5x plus 2y as x is 0 and y is 6. So 0 plus 2 into 6 is equal to 12. So the value of z at point A is 12. The next point is in the graph is B, whose coordinates we have measured as 3 and 4. So we will put B and x and value here as x column 3 and y 4. So the objective function z becomes z is equal to 5 into x is 3. 5 into 3 plus 2 into 4. Y is 4. Therefore, it becomes 5 into 3 is 15 plus 8. 2 into 4 is 8. 15 plus 8 is 23. Next, we will move to the point C. In C, coordinates are C. X coordinate is 5 and Y is 0. So, C, we have written the same thing. C as X equals 5 and Y equals 0. And we will substitute the value of C in the objective function Z. Z is equal to 5 into X, that is 5 into 5 plus 2y, 2 into 0, that is equal to 25. So if you compare the values in this fourth column, the values, that is, if you compare 0, 12, 23 and 25, 25 is the maximum. And the corresponding points for this value 25 are x equals 5 and y equals 0. We will write that. Okay. Maximum value of z is 25 and corresponding values are 5 and 0. It is written answer. In the graph, to find the coordinates of any point, you can also calculate it instead of measuring on the graph, which are lying outside the x-axis and y-axis. We can solve it and find the value of x and y by simultaneous equation method, which we have learned in our class 10. So a sample is shown in this text box. See where we have put 4x plus 6y is equal to 36, this equation, and 2x plus y is equal to 10. And we are calculating the value of x and y as shown in the diagram. You can note down and practice it. So next we'll take up another next question. Here the question is maximize p is equal to 2x plus 3y subject to x plus 2y less than or equal to 10, and the next constraint equation is x plus y equals x plus y is less than or equal to 6 and x is less than or equal to 4 and x comma y is greater than 4, greater than 0, sorry. So this equation, this problem we will solve it. Here the question is we have to maximize the profit, that is p equals 2x plus 3y. We have to maximize. Constraints are x plus 2y, first constraint. Second constraint is x plus y is equal to 6. And the third constraint is x equal 4. So we have equated all the constraint equations to their respective values on the right hand side. That is less than or equal to symbol is substituted by equal to, and greater than, and all the three are less than or equal to. So there is no problem. All these less than or equal to sign is replaced by equal to sign. So first table we will calculate. We will put x is equal to 0. We get y is equal to 10 by 2, that is equal to 5. And then y equal to 0 we will put here. If you put y is equal to 0, x is equal to 10. So these values, two coordinates we have put, that we have obtained 0, 5, 10, 0. For the next constraint equation, x plus y is equal to 6, we will also write a table. So in the table, when x is equal to 0, in this equation, x is equal to 0, y is equal to 6. When y is equal to 0, x is equal to 6. This is written in this table. So x is equal to always 4. So there is no other value. So now we will draw the graph. So as usual, select x-axis and y-axis on the left side and bottom side of the graph sheet. So using, you mark OX and OY as in the graph sheet. And then first mark the point x plus 2y is equal to 10 on the graph sheet. So first select 0 and 5. When x is equal to 0, y is equal to 5. So this is the point here. This is y is equal to 5. Next point is when x is equal to 10, y is equal to 0. Y is equal to 0 is the horizontal line at the origin. So that is y is equal to, x is equal to 10, y equal to 0. So this is 10. So you join these 2 points and you will get a straight line. This straight line you will get it. This is a straight line, though it is blinking, it is going zigzag way, but it is a straight line. Using your scale, you mark it. We'll next draw the next line, x plus y is equal to 6. So in this, you see the table, when x is equal to 0, y is equal to 6. The second line is here. This is x, y is equal to 6. When x is equal to 0, this is y is equal to 6. This point. And then the next point is x is equal to 6. When x is equal to 6, y is equal to 0. So this is the this point. So you join these 2 points of the second line and write its equation as x plus y is equal to 6. And previously it is x plus y is equal to 10. Therefore, now we are drawn 2 points. This is the point intersection. The third equation is x is equal to 4. X is equal to 4 is a line parallel to y-axis. So parallel to y-axis, this is the point. So you select the point 4 comma 0 here. Here y equal to 0 and x equal to 4, and this line you will get it. So you have got 3 lines. So next point, we have to mark all the shaded portion, mark the vertex, that is feasibility. So you see here, x plus y is less than equal to 10. See this equation, so all the equation should be on the left side, one thing. And it should satisfy x is less than equal to 4. So you observe this, x plus 2y is less than equal to 10. So x plus 2y is this relation, this equation. So it should be below that. It should be below this. So the next equation is x plus y is less than 6. So the equation should also be below this. So there are 3 conditions. One is the graph, the region should be below the line x plus 2y. So it is below the 2 line. So you should not select any region above this line. First. Now the second constraint is x plus y should be less than or equal to 6, or x plus y should be below 6, this line. So this is x plus y. So the region should be below this. Below this is this and this. So if you, and it should be x plus x is less than equal to 4. If you this in this region, left side is below 4. It should not fall above this. So this satisfied this region A, B, C, D, O satisfies all the conditions in the constraint. This is by examination. This shaded region OA, BC, DO represent the feasible region in which all constraints of the problem are satisfied. Hence, objective function, now we will copy, we will go to the objective function P is equal to 2x plus y and form a table. Table is shown here. The table has got vertices 0, A, B, C, D in the first column, and then x coordinate in the second column, y coordinates in the third column, and objective function in the fourth column. Now we will take at the origin. At the origin, we know x is equal to 0 and y is equal to 0. So x is equal to 0, y is equal to 0. Therefore, the objective function is 2 into 0 plus 3 into 0 is equal to 0. So next point is 0 and 5. So we get, so when you put x is equal to 0 and y is equal to 5 in this equation, we get 2 into 0 is 0 plus 3 into 5 is 15. Hence, the value of P is 15. The next point is B, whose coordinates are 2 and 4. So x is equal to 2 and y is equal to 4. We have put x is equal to 2 and y is equal to 4. Therefore, the given objective function P is equal to 2x plus 3y can be written as 2 into 2 plus 3 into 4 equals 16. The next point, we will take up the point, we will calculate P at point C. So therefore, point C is, coordinates are 4 and 2. You see here in the graph, 4 and 2. So x is 4 and y is equal to 2. So therefore, the objective function 2x plus 3y can be written as 2 into 4 plus 3 into 2. That is equal to 14. Finally, we come to the point D, where y is equal to x is 4 and y is 0. So the same thing is written here in this table. So that becomes 2 into 4 plus 3 into 0. These points B and C can be calculated, can also be obtained by solving the equations for the respective lines. These two lines, that is x plus y equals 6 here and x plus 2y is equal to 10 for this line. So at this point you can solve these two equations, and at this point you can solve x is equal to 4 if you put y is equal to y becomes 2. So that is the equation at C. So x is equal to 4, y is equal to 2. So these are the we have calculated. From the above table, from this table, you study these values after the equal sign. That is on the right hand side, 0, 15, 16, 14 and 8. If you observe and compare all the values, 5 values, 16 is the maximum value. So from the above table, we observe that the value of P, maximum value of P is 16 and corresponds to x is equal to 2 and y is equal to 4. That is the answer. Next problem. Determine the maximum and minimum values of z equals 4x plus y subject to x plus 2y is equal to or greater than or equal to 4, x minus 2y greater than or equal to 0, and x less than or equal to 6, x comma y greater than or equal to 0. So as usual, so we will solve it. X comma y is greater than 0. So the three constraint equations are written as it is, that x plus 2y is equal to 4, substituting greater than or equal to sign by equal sign in all the cases, and x minus 2y is equal to 0, x is equal to 6. And we will write the table for that. When x is equal to 0 in the first equation, y is equal to 2. So when y is equal to 0, x is equal to 4. So these 2 points we have obtained. For the next line also, we will write a table. When x is equal to 0, minus 2y is equal to 0. So y also is 0. These two, x is equal to 0 and y equal to 0, are written in the last column. So now, because there is no other, now if you put y, you will not get. So therefore, we will select an arbitrary value. You are free to select any value of x and y, x to calculate y. But if you take lower values, it is easy to calculate, and we select 0 because to cancel one term. So here in this case, particular case, we select x is equal to 4. If you select x is equal to 4, it becomes 4 minus 2y is equal to 0, or minus 2y is equal to minus 4, or y is equal to 2. So this is the equation. X is equal to 6 is as it is. And now we will draw the graph and identify the feasible regions. So as it is, we draw the graph as shown in the figure, x and y, horizontal coordinates, x-axis and y-axis are as shown in the figure. And we draw the equation x plus 2y. X plus 2y is here. This is the line. Now x minus 2y. X minus 2y is when x is equal to 0, it starts from x is equal to 0, y is equal to 0 is here. And when x is equal to 4, y is equal to 4, 2 points are selected and this line is drawn. This is a straight line. You draw the straight line. X is equal to 6. Here y is equal to 0. Y is equal to 0 is a line parallel to y-axis. Therefore, at point 6, x is equal to 6 is here, and you draw a vertical line which is parallel to y-axis or perpendicular to x-axis. So these three lines we have obtained. Now we have to mark the region. If you see the third region, x should be less than or equal to 6. So all the equations should be on the left side of the x is equal to 6, this region. And x plus 2y should be greater than 4. Greater than 4 is this region. So the region should be above this. And x comma y should be more than 0. So it is above this. So this is the region. Identified region is marked here. Write all the coordinates of the point vertexes B, C, D, A is the feasible region of the problem. Therefore, the shaded region B, B, C, D, or we will start with A, B, C, D, A is the feasible region in which all constraints of the given problem 4x plus y are satisfied. Therefore, we will draw the table of vertex and write their respective coordinates. So, vertex is A, B, C, D as in the column. X is 4, Y is 0, and then next X is 2, B is 2, B is the point 2, comma 1. So, 2, comma 1. And the C is 6, comma 3. We have written 6, comma 3. And D is 6, comma 0. So we have written the values of x and y for all the points A, B, C, D. So now we will calculate the objective function in the fourth column as given. So z is equal to 4x plus y. So when we put x is equal to 4, we get, and y is equal to 0, we get z is equal to 4 into 4 is 16. So the next is for point B, 4x plus y, that is 4 into 2 plus 1, 8 plus 1 becomes 9. At point C, z is equal to 4x plus y, that is 4 into, here the point is 6. 4 into 6 is 24 plus 3 is 27. At the point D, x is 6 and y is 0. Therefore, z is equal to 4 into 6, 24 plus 0, that is 24. If you examine the values here on the right hand side, that is 16, 9, 27 and 4, the maximum value is 27. We are required to find the maximum as well as the minimum value of z. So maximum is 27 and minimum is 29. So this is minimum and 27 is maximum. So we will write it in the equation. From the above table, we observe that the maximum value of z is 27 and corresponds to x is equal to 6 and y is equal to 3. That is the answer. And minimum also, you can write the equation. Minimum value is z is 9. Z is 9 and corresponds to x is equal to 2 and y is equal to 1. So that is, this is minimum where x is 2 and y is 1. This is the answer for your problem. Applications of linear programming. We have different types of problems in linear programming like manufacturing, the diet problem, and the transportation and other problems. In this section, we will take up some manufacturing problem and a diet problem. Let us start with question number 1. A factory manufactures two types of screws using two different machines. Using two machines, the time required for manufacture of one packet of each of the two types of screws on the two machines and the total time available of each machine and profit obtained on sale of each packet of two types of screws are given below. So details like in this, the firm is manufacturing two types of screws using two machines. The time required to manufacture one packet of the two types of screws on two machines is given. The time available, the availability of machine is also given and the profit is also given in the following table. Let us study it. So machine is given in this one. So machine, the time required, which machine takes how many minutes, and the screws and type of screws are given here. And the machine type for A screw, the machine one user produces the time it takes 4 minutes and machine 2 takes 6 minutes. And the profit for type of A screws per packet of screw is 8. So there is a B type of screw for which machine takes 6 minutes to manufacture and machine 2 takes 3 minutes. So, and the profit for this B type of screw is rupees 5 per packet. So, the availability of the time of machine for the first machine, the time available in hours. Here you write hours, 4 hours, and machine 2 also 4 hours. So what we are required to do is formulate. The question is formulate this as a linear programming problem and determine the number of packets of each of the two types of screws to be manufactured so as to get maximum profit, assuming that all the packets of the screws manufactured are sold. So we have to find the maximum profit. So this is a maximum profit. Our objective function is maximizing the profit. So let us solve it. Let X be the number of packets of type A screws and Y be the number of packets of B screws. Therefore, the total time taken for when machine works is, so this is the machine is working for to manufacture A, it is 4x plus 6y. That is 4x plus 6y. The total time for machine 2 is 6x plus 3y. We have to take vertically. For each machine we have to calculate. Therefore, now we have to put the objective function. Objective, it makes 8x. Profit in rupees is 8 into x. The x is the number of packets produced of type A and 5 is the number of packets produced for type B. So therefore P is 8x plus 5B, 5y. Now we have to calculate the time taken by each machine. Since two machines are available for almost 4 hours, that is equal to 240. 4 into 60 minutes, that is equal to 4 hours are converted into minutes, that is equal to 240 minutes. We have 4x plus 6y is less than or equal to 240 and 6x plus 3y less than equal to 240. So objective function is 8x plus 5y, which we have to maximize. Subject to the constraints are 4x plus 6y should be less than or equal to 240 and 6x plus 3y should be less than or equal to 240 and x comma y should always be greater than 0. Now we have to draw the graphs of these linear equations. We will continue in this slide. So the linear equations from the previous page are 4x plus 6y is equal to 240, 6x plus 3y is equal to 240, x comma y is greater than 0. Draw a table to draw a table to get the coordinates of first line. That is when x is equal to 0, y is equal to 40. When y is equal to 0, x is equal to 60. Similarly, for the second constraint, when x is equal to 0, 3y is equal to 40 or y is equal to 80. When y is equal to 0, x is equal to 40. So this we have obtained. we have to draw the graph. Take a graph sheet, a pencil and a scale. Select a origin on the left hand side of your graph sheet, leaving some margin, and select point of origin O and draw a horizontal line, x-axis OX. On this you draw a vertical axis OY. These two are drawn. So we will now plot 4x plus 6y. 4x plus 6y, we get 0 and 40 here. When x is 0, y is 40. And when x is 0, when x is 60, here x is 60, y is 0. So this is the line. Second line is 6x plus 3y is equal to 40. So when x is 0, y is 80. So this is the point of second line. And when y is 0, x is 40. So this is the point. So second line is this. Previously, we had drawn the first point and first line as this. This is the first line. That is, the equation for this line is 4x plus 6y. And equation for this line is 6x plus 3y equals 40. This is all. So, if both are falling, x comma y is greater than 0 and it is in first quadrant. So now we have to find the intersection. Intersection points are, of the two lines in this are B. B coordinate we have to measure from the graph. We measure it as 30 and 20. 30 comma 20. That is x is 30 and 20. These equations, the values of x and y at point B can also be found by using simultaneous equations of these two lines. You can do it. Now we have to select the range, identify the feasible connections. Here, the given constraints are 4x plus 6y should be less than or equal to 240. So the 4x 4x plus 240, it should be below this line. So this is the region, and it should also be less than 6x plus 3y. 6x plus 3y is this line, and the region should be below this. So this is the region selected. That is A, B, C and O is the region selected. The shaded region is OA, BC, DO. Represents the feasible region in which all constraints of the problems are satisfied. And from our previous page, the objective function is 8x plus 5y. Therefore, having located these coordinates, we will write the vertex and its respective coordinates. So, point O is 0, 0, we know. Point A here is, 0, comma 40. So, these values are written, 0 and 40 are written there. And for point B, it is 30 and 20. So, we have written 30 and 20 here. And for point C, the coordinates are 40 and 0. So, 40 and 0. Now, objective function is 8x plus 5y. We will calculate objective function for these values. So, therefore, 8x plus 5y is 8 into 0 plus 5 into 0 is equal to 0. Then, at point A, where x is 0 and y is 40, p is equal to 8 into 0 plus 5 into 40. That is equal to 200. At point B, p is equal to 8 into x. X is 30 plus 5 into y. Y is 20. So, 8 into 30 is 240 plus 5 into 20 is 100. So the value is 340. At point C, x is 40 and y is 0. Therefore, P is equal to 320. And comparing this, we observe that the maximum value is 340, for which x and y are 30 and 20. From the above table, we observe that maximum value of P is 340 and corresponds to x is equal to 30 and y is equal to 20. Hence, maximum profit is 340 and corresponds to manufacture of 30 pockets of A and 20 pockets of B types of screws. Let us take up the next problem. Question number 2. The production of two types of suitcases requires processing and completion to be done on two machines A and B. The time required for processing and completion of each type of trunk on two machines the time available on each machine and profit of each type of suitcase is given below. So suitcase is on the horizontal side and machine is on the vertical down. So time square required is 1 is for A type machine takes 3 minutes and um, for type A, type 1 and for type 2 it takes 3 minutes. And total profit for A type of packet is 18 rupees. And for B type, it is 2 and 4 respectively, where profit is 16 rupees 16 per suitcase. Determine the number of two types of suitcases to be produced to get maximum profit. Solution. Let x and y be the number of type 1 and type 2 suitcases to be produced. Therefore, then the total time taken by machine A is 3x plus 3y. The total time in machine B is 2x plus 4y. Please note here it is horizontally. The machine is here and it is taking 3x plus 3y and 2x plus 4y. Therefore, the total profit P is 30x plus 42y, because it is the profit in suitcases, it is given here 30x plus 42y. So type 1 suitcase and type 2 suitcase. Therefore, since two machines A and B are available at most for 18 and 16 hours respectively, we have 3x plus 3y less than or equal to 18 and 2x plus 4y less than or equal to 16. Therefore, the linear programming problem is to maximize P is equal to 30x plus 42y. Therefore, subject to constraints are 3x plus 3y it should be less than or equal to 18. 2x plus 4y should be less than or equal to 16. X comma y should be greater than 0. These are the constraints. These three constraints are given here. Please note in the last column it is the time available in hours. Time available hours is 18 hours for machine A and 16 hours for machine B. Total time hour. That is the constraint. Time availability of machine. So now we have written the objective function and constraints. Two equations for constraints and one objective function. Now we draw the linear equations for this. From the previous slide, we have seen that the objective function p is to maximize p equal to 30x plus 42y subject to, there are two constraint relationship. 3x plus 3y should be less than or equal to 18. 2x plus 4y should be less than or equal to 16. And x and y should be greater than or equal to 0. That is as usual for all the cases. So solution will continue. So two equations, constraint equation 3x plus 3y is equal to 18 and 2x plus 4y equals 16 are written. And we will find out the method to draw the equations for these lines. So see the table column for the line 1. Say line 1 is 3x plus 3y. Now we will put x is equal to 0 here. We get 3y is equal to 18. Therefore y is equal to 18 by 3. That is equal to 6. The next step is when we put y equal to 0 in this equation, we get 3x is equal to 18 or x is equal to 6. So in this case, when x is 0, y is 6. And when y is 0, x is 6. So we have found it. Now we will find the coordinate for the next line. 2x plus 4y is equal to 16. So if you put x is equal to 0 in this equation, we get this becomes 0. 4y is equal to 16 or y is equal to 16 by 4. That is 4. So when x is 0, y is 4. Now next step is to put y is equal to 0. In this step, we will put y is equal to 0. So y is equal to 0. When we put y is equal to 0, see this term becomes 0. 2x is equal to 16 or x is equal to 8. Now we will draw the graph of these constraints equations identifying the feasible regions. So please draw the take a graph sheet, a pencil and a scale, and on the left side leave some margin and draw a vertical line and a horizontal line. Mark the point O. O is the origin of intersection of x axis and y axis. Let it be 0, 0. Now we have to draw the equation 3x plus 3y is equal to 18. That is 0, 6 and 6, 0. If you see when x is 0, y is 6. This is the point. And when y is 0 is x-axis and x is 6. So x is 6 we get here. So when we join these 2 points, we get this line of the first line. So we have drawn the first line on the graph sheet. Now we will draw the second line. The second line relationship is 2x plus 4y. When x is 0, y is 4. So this is x is 0 and y is 4 is this point. And the next point here for the second line is when y is 0, x is 8. So y is 0 is at x-axis and x is 8. So 8, 0 is here. We get the point D. So when we join these 2 points, we get this equation. So we have drawn the 2 lines. Now we have to mark the feasible regions. So see 3x plus, this is 3x plus 3y. So 3x plus 3y should be less than 18. So our this constraint is it should be less than 18. So this is the region on the below this line, and then 2x plus 4y. 2x plus 4y is this line and it should be below this. So the adjoining line and cross section is marked here. This is the corresponding region. which we are required to find. So now you note down the region, the feasible region is O, A, B, C, O. This is the feasible region. In this range we can operate. So now note down the coordinates of all the points. It is O is 0, 0, A is 0, 4, B is 4, 2, and C is 6, 0. So all these points are written here. Vertex are 0, A, B, C. And X and Y is for O, it is 0, 0. For A, it is 0, 4. Please see the diagram. And for B, it is 4, 2. It is 4, 2. And C is 6, 0. See, this 4, 2, you have to mark it and obtain it from the graph. What is the coordinate by measuring, actual measuring the scales on the x-axis and y-axis. You will get 4, 2. You can even get it by solving the equations. 3x plus 3y is equal to 18 and 2x plus 4y is equal to 16. That is the equation of these two lines at the point of intersection. We know the method. Now we have noted down the coordinates of OABC. And now we are required to find, we have also already know it is, we have formulated the maximize the profit function as P is equal to 3x plus 30x plus 42y. So 30x plus 42, when we put x is equal to 0 and y is equal to 0, we equal to 0. Therefore, P is equal to 30x plus 42y. X is 0 and y is 4. We get 42 into 4 is 168. So the next point at B is x is 4, y is 2. And substituting in the objective function, we get 30x plus 42y is equal to 30 into 4 plus 42 into 2. That is equal to 204. At point C, all the points we have to calculate. At point C, x is 6, y is 0. Therefore, P is equal to 30x plus 42y, that is equal to 30 into 6 plus 42 into 0, that is equal to 180. So if you compare all the values on the right hand side of column 4, we get 0, 168, 204 and 180. So here the maximum value is 204. So for this value, this is the maximum, the profit is maximum. So let us note down the point. From the above table, we observe that maximum value of P is 204 and corresponds to x is equal to 4 and y is equal to 2. This red ink should come afterwards. You should not write this in. I have used red ink to clearly differentiate between this value and other values. Blue ink, red ink only to draw your attention. In your examination, you have to use permissible ink, that is blue, black or blue ink only, blue pen only. Don't use red and all that. You have to use the normal values and then you have to underline. Okay. So hence the maximum profit is 204 and corresponding to manufacture of 4 numbers of type 1 and 2 numbers of type 2 suitcases. This is a suitcase problem. Is a diet problem. Question 3. At a cattle rearing, it is prescribed that the food for each animal contains at most 16 units of nutrient A and at least 24 and 40 units of nutrient B and C respectively. Two types of fodders are available. The number of units of these nutrients contained per kg by the two types of fodders and their cost per kg is given below. So the table gives the values of content of nutrient, fodder 1, fodder 2. So nutrients are, there are three types. Nutrients, contents of nutrients per kg. That is nutrient A, nutrient B and nutrient C. There are two nutrients and the cost is given in the fourth column. Fodder 1, there are two fodders, fodder 1 and fodder 2. Fodder 1 is A is 1, B is 3 kg and C is 2 kg. And fodder type 2 has 1 kg of A, type A nutrient, and type 1 kg of type B nutrient and 6 kgs of 6 type C nutrients. And after making all this, it is found that the cost per kg in rupees is, cost is 12 for fodder 1 and rupees 15 for fodder 2. Now, by graphical method, determine the number of kgs of two types of fodders to be purchased so as to make the cost a minimum. Note here, cost should be minimum. So, we have to find the minimum value in our final answer, yet meeting the requirement. Solution. So, let x and y be the kgs of fodder 1 and fodder 2 be purchased. So, we are purchasing here. Then the cost of C, here type C is 12x plus 15y. So the cost column you have to write 12x plus 15y, cost column. The total contents of nutrients of A, B, C are fodder 1 is x plus y and then it is 3x plus y and 2x plus 6y. So fodder 1 is x plus y. This is x is 1, y is 1. B is 3x plus y plus 2x plus 6. So these are the combinations because x per kg, x and y kg of fodder 1 and fodder 2 be purchased. Since the contents of A is at the most 16 kg, so it is given 16 units of nutrient. Animal contain 16 units of nutrient. So constraint is A is at the most 16 kg while it has to be 24 for B and 48 for C. Therefore, x plus y should be less than, this is A, this is fodder A. So it is the nutrient A is 16. So it is x plus y should be less than or equal to 16. And while it has to be 24 for B, that is x3x plus y should be greater than or equal to 24. So the third point C is 2x plus 6y should be greater than or equal to 48. It is given, you see here, for C it is given, for A it is also given 16 kg and B is equal to 24 for B. It is given. So now the cost function is LPP is to minimize Z is equal to 12x plus 15y. Therefore, subject to x plus y is less than or equal to 16. Therefore, 3x plus y should be greater than or equal to 24 and 2x plus 6y greater than or equal to 48. Therefore, x and y should be greater than or equal to 0. We will continue in the next slide. We will continue our solution from the previous slide. So, we have written in the previous page the objective function z equals 12x plus 15y and constraint equations are x plus y is less than or equal to 16, comma. The second constraint equation is 3x plus y greater than or equal to 24, comma, And the third constraint equation is 2x plus 6y greater than or equal to 48. And as in all other cases, x comma y is greater than or equal to 0. Hence, we will first start with our constraint equations. Let us write down the constraint equations as x plus y equals 16. That is, this is we have replaced less than or equal to by an equal to sign. And the next equation is 3x plus y is equal to 24. And the third equation is 2x plus 6y is equal to 48. So the table of xy we will write as in the previous problems. When x is equal to 0, y is equal to 16. That we have written here. X is equal to 0, y is equal to 16. And the next is y is equal to 0, x is equal to 16. 0 and 16. Similarly, we will find the points for the straight line 3x plus y is equal to 24. So when x is equal to 0, y is equal to 24. It is written here, x is equal to 0, y is equal to 24. Similarly, when y is equal to 0, when we put y is equal to 0 here, 3x is equal to 24 or x is equal to 24 divided by 3, that is equal to 8. So these two values are written here in the third column of equation 2. The next equation is 2x plus 6y is equal to 48. When we put x is equal to 0 in this third equation, we get 6y is equal to 48 or y is equal to 48 by 6 or y is equal to 8. So this x is equal to 0 is here and y is 8. Calculated value is 8 here. And the next step is put y is equal to 0 in this equation. So therefore, if you put y is equal to 0, 2x is equal to 48 or x is equal to 24. Hence, we have also got 2 points for drawing lines 2x plus 6y is equal to 48. And in similarly, all the 3 points we have calculated. Now let us draw the graph of these constraint equations given above and identify the feasible regions. So the graph can be drawn on a graph sheet. Please take out a graph sheet on the left side and at the bottom, leaving some margin space for margin, mark the origin O here. And draw line OX in horizontally and OY vertically as shown here. Then the next point is draw equation x plus y is equal to 16. So when x is equal to 0, y is 16. So x is 0 here and y is 16 here. So this becomes a point for the line x plus y is equal to 16. The next step is you mark the point 16, 0. So when x is 16, y is equal to 0. X is 16 is here and y is 0 here. So you join these 2 points to get this straight line x plus y is equal to 16 on your graph. I hope you have got this. You have come up to this point. The next step is to draw the line for equation 3x plus y is equal to 24. This equation. So we will first mark point 0, 24. X equals 0 is here and x is 24 is here on the line, on the scale. So this is a mark. Mark the point here, E here, point in your graph sheet. That is the first point of the second line. And then the next point for the second line is when x is equal to 8, y is equal to 0. X is equal to 8 is on the x-axis. X is equal to 8 is here. And y is equals 0. Y equals 0 is, sorry, x is equal to 8 y is equal to 0 is this point. This point. So previously we have found E 0, 24, F 8, 0 is here. So this straight line we have drawn. The third step is to draw the line 2x plus 6y is equal to 48. Therefore, the first point for this equation line is x 0 and y 8. So 2x 0 and 8. So x is 0 here and y is 8 here. Let this point be A. 0 and 8 is here. And the next point for this line 2x plus 6y is x is equal to 24. X is equal to 24 is here and y is also 0 here on the x-axis. You join this point, 2 points, to get this third line. So we have drawn three lines and we will mark them as A, B, C, D, E and F. These are the points as shown in the diagram and the graph sheet. Now, the next point is to find the vertices. Mark the feasible region. Now, please go back to the constraint equations. X plus y equals 16, x plus y is equal to 16 is this line. So, constraint is x plus y should be less than or equal to 16. So, our region should be below this line. And next is 3x plus y should be greater than or equal to 24. So this 3x plus y equal 24 is this line. So the region should be towards the right because it should be greater than 24. So it should be on the right hand side. The third line is 2x plus 6y is greater than or equal to 48. So this is the line and it should be greater than 48 means it should be above this line. So this is the region. The feasible region between three lines. So the line 1, this is line 1, line 2 and line 3 and this is the feasible region and we will mark the vertices of this region. The vertices are L, M and N and if you measure their coordinates on the graph sheet you will get L as 12 and 4. This you will measure it as 12 and y-axis is 4 and M is 6 and 6. So it will be 6 here bottom and y also 6 and N will be 4 on the x-axis and 12 on the y-axis. These coordinates we will write in the next table. Table of vertex is given here. Please see the vertex table. Vertex are M, N and L. So x will be, when x is 6 and y is 6 for this point M, we have copied the objective function z is equal to 12x plus 15y. We will write here 12x plus 15y and put the value of x as 6. So it will be 6 into 12 plus 15 into 6 is equal to 162. And the next point is n. N is equal to, for n the coordinates are 4 and 12. So for z, the objective function z is equal to 12x plus 15y, we get 12 into 4 plus 15 into 12. That is equal to 228. And the next point is L. L coordinates are 12, x is equal to 12 and y is equal to 4. Therefore, the objective function z is equal to 12 into 12, that is 144, plus 15 into y, that is 4. So we get 12x plus 15y is equal to 206. From the above table, we observe that the minimum value, we are required to find minimum value, that is cost function. Minimum value of z is 162 and corresponding to these points x is equal to 6 and y is equal to 6. Therefore, in order to make the cost minimum, 6 kgs each of order 1 and 6 kgs of order 2 are to be bought, and its cost is rupees 162. We can also find the x and y coordinates of points M, N and L using simultaneous equation of linear equation. One example is shown here. Let us see, solve x plus y is equal to 16 here. X plus y is equal to 16, and the second equation is 2x plus 6y is equal to 48. If we solve it, we get the value of y as 4 and x as 12. So these values are substituted for L as 12, x is 12 and y is 4.